Welcome to 2.5, Solve Equations with Fractions or Decimals. I know this may not sound as your favorite section, but I'm going to try my best to win you into understanding fractions and decimals and actually ending up liking them. So we have two objectives here. We have solve equations with fraction coefficients and with decimal coefficients. Let's take them one by one. Solve 1 over 8x plus 1 over 2 equals 1 over 4. Clearly, this is a case where we have fractions, not decimals. There are two ways to do this, so perhaps I'll call this method 1. This is using the general solving strategy that we saw in the previous section, which is to do the same steps as distributive property, combine like terms, isolate x on one side, take the numbers on the other side, and solve the equation. So, which means we're going to keep these as fractions itself, okay? Plus 1 over 2 equals 1 over 4. And because your x is already on one side and no other x terms, there is no room for us to combine like terms. There's no need really for us to do that. So I have to subtract half on both sides because those are numbers, plain numbers, okay? All right, so again, this is a case where you want to see them done separately, like this. It's a 1/4 minus a half. Well, you can understand this perhaps intuitively. That's one way to do it, but you want to do it in a mathematical way, which means to find the LCD. The LCD between the two denominators is 4, which means you adjust the 2 here and the 2 up and down so that you have the same denominator, 4, right? 1 over 4 minus 2 over 4. Now that you have same denominators, you could simply do the 1 minus 2, which is negative 1 over 4. All right, that was by the side. So you always do some margin work to actually bring that answer back into those steps. So 1 over 8x equals negative 1 over 4. Okay, so we got x on the left, number on the right. We need to get x by itself. One more step. You want to multiply both sides by the reciprocal of the number that's attached to your x. 1 over 8 is attached to the x. Its reciprocal is 8 over 1. Remember, reciprocal is simply flipping their positions. What I do on one side, I also do on the other side. All right, the whole idea, because of the systematic approach, will take care of eliminating the 8s. But on the right as well, it works because 4 and the 8 cancel off evenly, giving us a 2. X equals, we have a negative there, and 2 is the leftover. So x equals 2 turns out to be the answer, okay? Of course, you'll have to do the check. This is method 1, okay? In method 1, we kept the fraction as it is. We did a side work where we handle the fractions by taking the LCD and doing all that. And then we came back to insert the answer into the step and continued with the step of isolating x, and we got the answer. Let's do method 2. If this is fine, this should be fine with you because you're used to handling fractions in pre-algebra. But and for most reasons, we like to see an equation without fractions just so we can avoid, unintended errors and so on. So this method is the clearing fractions method. Let me copy the question again. 1 over 8x plus 1 over 2 equals 1 over 4. Clearing the fractions requires us to take care of clearing the denominators because the fraction, the problem in fractions is where the denominator, is hanging in there. We want to get rid of them, eliminate them. So again, remember when it's fractions, you really can't escape LCD. So if you think you want to skip LCD, well, you cannot do that. You either do the LCD in a different step, or you do it upfront like in this method. LCD for all the, or let me put it this way, let me clear that. LCD of 8, 2, and 4, because these are denominators, right? So you need to take the LCDs of all these three numbers. In other words, you want to see how to turn all these denominators to be the same. Well, the LCD turns out to be 8. Okay. And the technique says multiply each term by LCD. Okay. It basically means multiply both sides. I'll write that. Both sides. But internally, both sides means every term is multiplied by the LCD. I like to do the every term part so that students do not forget or skip the main part of distribution. Because when you just put 8 on both sides, you forget to distribute it to every term. So I always insist that we do it for each term. So 8 is my LCD. I multiply by 8 for the first term, multiply the second term, multiply the third term. By virtue of LCD, it should clear all your fractions, isn't it? That's the whole point. That's the whole point of finding the LCD and using it to clear the fractions. They must all divide out, leaving you with no denominators. If you still have denominators lingering, obviously your LCD is wrong. So x plus 4 equals 2. Look at that. That's very, very nice because you cleared all your denominators and you're collecting all the leftover terms from the previous step. Now that you have x already by itself on the left, you just have one more step of moving the 4 over to the right. X equals 2 minus 4, negative 2. Again, I insist that you perform the check. And upon checking, we will know that x equals negative 2 is the answer. But we also know it because we did the same problem in method 1 and we got x equals negative 2. You should get the same answer no matter what method you choose. But as you can see, method 2 is preferable because you take care of that fraction right away. And LCD is again something you're familiar with from pre-algebra. If you're not familiar with it, please watch other YouTube videos, or Khan Academy is a good resource. You can go there and refresh yourself of those types. Also, OpenStax has Algebra Foundations as Chapter 1, which is your pre-algebra concepts. Go back there and refresh as well. Okay, let's perhaps do one related to your fractional coefficients when you have multiple ones. So I'll do one more of the fraction, but a slightly different style. So solve 6 equals 1 over 2 v. Okay, that's my v, it's in cursive. I like to do the cursive because I do not want it to be mixed up with my numbers. I've been doing math for a long time. I know how it can hurt if you confused your numbers with letters, particularly the x and 9, 7, all these things. You know, if you are a sloppy writer, you're going to have a big issue dealing with them later. So develop good habits. Exaggerate your letters so they stand out. Okay, we're going to do method 2. Which is clearing the fractions. So I look at the LCD of 2, 5, and 4. That's going to give you a 20. And do you recall the LCD is where you do the tree diagram and all that? So, you know, all that has to happen in the background. And then you get your 20 as your LCD. So your equation is 6 equals 1 over 2v plus 2 over 5v minus 3 over 4v, right? And we're supposed to multiply both sides by the LCD, right? That is the clue to clear the fractions. But as I mentioned earlier, I don't like to do it like this because what students tend to do is forget that the 20 on the right side distributes to each term on the left, right, within the parentheses. So because some of you would have learned it this way, which is not wrong, it's just that we don't want to bring that confusion there. So I'll just do this. Every term I write out with a little gap, so I could use that space to multiply the 20. That's what will happen when you distribute the 20, right, to each term. Instead of doing that previous step, I directly multiply every term by 20. That's the difference in what I do versus what you probably have learned previously. All right, again, by virtue of your LCD, they must all cancel off nicely, leaving you with no denominator. All right, on the left we have 20 times 6, which is 120, equals the leftover number is 10 with a v. 4 times 2, 8v, 15v. All right, so that looks really nice. And your right side actually has all the v's already in it. So that's one less work for us. So all these are like terms. So please combine them. They all look alike. They have identical variable with identical power, so you can combine them. Doesn't matter if it's all happening on the right side, right? It's an equation. Shouldn't be a problem. Okay, 18 minus 15, 3v. We'll divide both sides by 3. Cancel off. And here also it cancels off. So 3 times 1 here, 3 times 4, and that's 0, 40. That leaves us with 40 equals v. See how quickly we got our answer? Again, please perform the check and confirm that that's your answer. And for the sake of our course, we would like to do method 2 so that we are all on the same page and how we get our answers. All right, it's time for us to move to fractions, move away from fractions to decimals. So with decimal coefficients, solve 0.06x plus 0.02 equals 0.25x minus 1.5. Here again, you could handle your decimals as they are and use your calculator. But as you can see, there are a lot of decimals with a 0 following it and some without the 0 following it. So you really, really, really want to be very careful. Here again, the trick is to clear your decimals so that you can handle them as whole numbers. Okay? So clearing decimals is the way we're going to do here. To clear decimals, we need to take account of how many decimal places we have in each term. Okay? So I'm going to write the problem again. 25x minus 1.5. Okay. Now look at the number of decimal places and make a little note. Okay, there are 2 decimal places. Two decimal places. 1 decimal place. So once you have identified the number of decimal places, choose the one that's the highest. Okay, so we have 2 as the highest. So 2 is what we choose. The 2 represents 2 zeros for your number to multiply. Okay, so this means this whole equation is being multiplied by 100. Okay, 2 for the 2 zeros, because that is how you flush out the decimal to the right, clearing your decimals. Because if you want, this is something you learned in pre-algebra, but you could actually test it with your calculator. 0.06 times 100 actually gives you a 6, because it moves the decimal 2 places to the right. That's the whole idea. Now here I have only one decimal place. I have to insert a 0. Okay, that's one thing you have to remember. So this becomes 6x plus 2 equals 25x minus 1, 5 with a 0, because you have to move to 2 decimal places. You only had 1 decimal place, only a 5 was the only decimal position there. So you have to move 2 places though, which means you insert a 0. Just like that, you cleared all your fractions and you got this. Okay. Yeah, now we need to collect all our x's on one side. Okay. Now I could collect all the x's on the left. If I want to keep it that way, that's totally fine. We could also collect it on the right, because if I collected it on the right, I'll get a positive x. But I just like to stick to what I mentioned before, which is collecting them on the left. So that's totally fine to have a negative result for the x, because we're going to take care of it when we isolate x. All right, 6 minus 25 will be negative 19x plus 2 equals negative 150. Now let's move the 2 over to the other side, because we want to collect all the numbers on the other side. That goes away. Negative 19x equals negative 152. Okay. All right, now we need to isolate x. So divide by negative 19 on both sides. You want to do the negative 19 because you want your x without the negative sign. So x is by itself. Negative over negative is positive. 152 over 19 in your calculator gives you 8. Okay. Again, perform check and confirm your answer. X equals 8. So clearing the fractions and clearing the decimals is the way to go. Okay. However, in checking these ones, you have to keep them in the decimal form. Okay, that's the only catch here. So you know what? I'll just do the check, just to highlight to you that you will not tamper with the original question. 0.06x plus 0.02 equals 0.2. I'm sorry, it was 0.25 from right. It's 0.25 x minus 1.5. All right, 0.06 with a shell, 0.02, 0.25 with a shell minus 1.5. Okay. X was 8, plug in the 8, multiply them out. Okay, that will be 48, so 0.48 plus 0.02. That will be 200 to 0.00 minus 1.5. All right, so then you say all this is mostly used is in the calculator. So that will add up to 0.5, 15, so 0.50, and that will be 0.50. Again, it's 0.5, 0.50 just because you had 2 decimal places. That's it. Your calculator most likely will give you 0.5. The check works, and you come back and verify your answer. Okay, we'll do another one. Solve. Okay. 0.25 n. We have another 0.25 again, right? Let's do a different one. Let's not do the point. Okay, 0.10D plus 0.05D. Oh, there's a D minus 5 in parentheses. It's 2.15. Okay. Let's distribute 0.10D, 0.05 D minus 5 equals 2.15. Okay, at this point, we could distribute, okay? But before that, because once you distribute, you get the distribution also in decimals. But the whole point is to clear them. Because they are, the 0.05 is actually outside, the parentheses. You could actually clear the decimals there because there's no decimal inside the parentheses, so that's kind of helpful. Okay, so this has 2 decimal places, 2 decimal places, and 2 decimal places. So 2 is the highest number, which implies that you're going to multiply both sides by 100, or each term by 100. Okay. Last time I just moved the decimal point by just moving the arrow. But if you want to use a calculator, that's fine, but that's going to be unnecessarily lengthy. But what the calculator does is it gives you a clarity on what answer you get. So in that sense, you will know if it's a 10 or just a 1, right? So anyways, this is a 10D plus 5 times D minus 5 equals 215. Now we're ready to distribute because that's a breeze. 10D equals, I'm sorry, not equals. 10D plus 5D minus 25 equals 215. And we combine the like terms on the same side. Those two are like terms. They happen to be right next to each other. That's 15D minus 25 equals 215. Now we need to add 25 on both sides. That gives us 15D equals 240. Divide by 15, divide by 15. And 240 over 15 comes out as 16. Okay. Again, do the check. Declare it as your answer. As always, plug it in your original equation, which contains decimals, to do your check, and then come back to confirm your answer. That's it, class. I'll see you in the next video.